Very good afternoon to everyone and welcome to this lecture of CAD-CAM. Today we are going to discuss about computer integrated manufacturing, that is SIM. So let me share the screen. Okay, can anyone just tell me if it is visible to you? If the screen is visible to you, just put a message in the chat box. Is the screen visible? Yes, okay, no issue. So let's go on to the discussion. So we are discussing the final chapter of this subject CAD-CAM. A lot of topics we have already discovered, covered, discussed. Today we are going to discuss about computer integrated manufacturing. So as its name implies, it is the integration of computer with manufacturing. So we have idea about computer aided design, computer aided manufacturing. So aided means we are taking help from it to a certain extent, right? And integration means we are taking help from the computer or computerized system to very large extent. Rather, we can say that it is a totally computer dependent manufacturing, computer integrated manufacturing. Okay, so that is the basic difference between CAM and SIM. Okay, let's move to the definition. Okay. Okay. So the definition of SIM is that. Let's read that. SIM, computer aided integrated manufacturing, is the integration of total manufacturing enterprise through the use of integrated systems and data communications coupled with new managerial philosophies which results in the improvement of personal or organizational efficiencies. This is the standard definition of SIM. This could be asked in exam. Write the definition of SIM. So you have to write this complete definition. Now let's discuss this definition. What exactly it tells about the SIM or computer integrated manufacturing. So it is the integration of total manufacturing enterprise. So we are not discussing about some part of planning, some part of quality, some part of production, some part of dispatch. Nothing. We are discussing about total manufacturing enterprise of the industry, how through the use of integrated systems and data communications. Integrated systems, all these functions are integrated, and data communication, it could be one-way data communication, it could be two-way data communication. So if you remember the open loop and closed loop feedback system, in one system we give feedback to the computer control system or computer unit, control unit. One way communication is there, and in another type two-way communication, we are giving the input also and we are taking the output also. So data communication coupled with new managerial philosophies. Now this is a interesting part here, because till now we were discussing about the manufacturing, design, quality control, etc., etc., which were physical, we were that were tangible. We used to see that, we could touch that, we can just go through and manage it. But now we are dealing with philosophies. Philosophies are virtual, they are intangible. We cannot touch the philosophy. Okay, they are virtual only, but they are also coupled with the data communication and integrated in the system. and what we are getting out of this all this exercise, which results in the improvement of personal or organizational efficiency. So our target of using SIM is to improve the efficiency of a organization, or it could be a person. Personnel means, don't complicate this word with personal. Personal means not mine, my efficiency. No. Personnel means the efficiency of the workers, the staff members working in an organization. So it depicts that it could be used in service industry also. It is not like that we are using this in manufacturing industry only. So the personnel means the staff, working people in the industry. The efficiency of that personnel could be improved, or overall organization efficiency as a manufacturing unit could be utilized or improved rather. Okay, so this is the definition of SIM. If you remember this definition clearly, if you understand this definition clearly, you are going to have a good knowledge of SIM and how to implement that. Let's move further. Just a minute, I have to move this here. Where to move this? Okay, now, to go into the SIM, we just have to quick remind of manufacturing systems that we are going to use. There are three types of manufacturing that you know already. The first one is called as continuous production system. The second one is called as mass production system, and third one is a job shop production. I hope you understand the difference between all these three. Continuous means these could be, you can call it as a batch continuous process production, or you can also call it as a batch production system. You are using the machinery continuously, but you are manufacturing in batches. Then there is mass production, which is very continuous, and the product mix, the different types of products in this case will be very less. Okay, but you are using the production system on continuous production type. This is called as mass production. And third one is a job shop production, where a larger product which is very sophisticated, very high technology used product, that kind of products could be manufactured by using job shop production. The advantages, disadvantages, I hope you know earlier, because this is very basic thing in manufacturing. Okay, so among these three, the mass production and job shop production can be categorized as discrete item production. The batch production is not a discrete item production. The job shop and a mass production system can be seen as discrete item production. This point you have to remember. Now let's move further. The continuous flow process cannot be automated fully. The first type, that is batch production, cannot be automated fully, as it only consists of small percentage of manufacturing system. Keep this in mind. The batch production system or continuous flow process system, you can call it as a, you can consider it as a system which has small percentage of manufacturing system. Okay. The second type, mass production of discrete item, is included in this category, where segment of production line are largely automated, but not the entire line. You are getting it? In first case, small percentage was automated. In the second type, mass production, a segment of production line, which is not a small, which is more than small percentage. Okay, segment of production line is automated, but not the entire line. Okay, now in third case, the job shop facilities have used automated machines, but transfer of work among these machines is a difficult task. So we can say that job shop facilities of job or job shop production system can be considered as totally automated. It can be totally automated from raw material to the finished product, but the transfer of work from one place to another place or one workstation to another station is a difficult task in case of job shop facility system. So these are the three things you must understand before going to SIM. Now let us discuss what are the challenges faced by a manufacturing engineer while using these kind of philosophies, these kind of techniques in his day-to-day work. Okay, so as a manufacturing engineer, what are the three things you have to go through every day, or what are those challenges? The first one is cost. The cost must be reduced, right? The second one is delivery time. The delivery time of product to the customer must be less, right? You can see the diagram over here. And you are forced or you must stress upon improving the quality. As you can see the arrows here, the quality must be improved, the cost must be reduced, and the delivery time should be reduced. So these are the challenges for a manufacturing engineer. Okay, this is just a explanation of this whatever just I have told. Okay, now SIM has several software tools to address these above needs. So basically these 3 points where we are going to focus to implement the SIM, that is computer integrated manufacturing, by using several software tools. Now let's go in further deep. The SIM involves a fundamental strategy of integrating manufacturing facilities and systems in an enterprise through the computer and its peripherals. So we are going to use computerized systems and computer peripherals to integrate manufacturing facilities and systems in an enterprise. The same involves integration of advanced technologies in various functional units of an enterprise. So second thing is we have to use or we have to integrate advanced technologies like CNC machine, DNC system, like that. Okay, and how in an effective manner to achieve the success of manufacturing industry. So obviously any manufacturing industry will have the first and foremost goal is to make profit. Everything, every organization, let it be a service sector, let it be a industry like manufacturing product sector, the most and foremost uh, objective is to make money, obviously. Okay, so that objective, to achieve that objective, you should use these different types of tools and technologies and techniques and methods and philosophies so that your target is achieved. Now, a deep knowledge and understanding of all the technology is required for effective integration. If you are trying to implement SIM in your organization and you or the person who is going to look after this, he does not know detailed about the technologies used in the industry or how this new technology is being used, then it is very difficult to implement SIM in an industry. So a deep knowledge of knowledge and understanding of all the technologies that we are going to use in the industry is very important. Okay, let's move further. Now, how we are going to implement the SIM, that we are going to discuss in brief. At first, integration of advanced manufacturing technology, that is AMT, abbreviation as, is required to get success in the application of SIM. So you must know what are the advanced manufacturing technologies right now in the market. Then computers will act as a subordinate to the technologies. The technologies are different, This could, the technology could be computerized technology, but the computers will be subordinate part for that technology. It will help the technology to proceed. Okay, then they will also help to organize and to restore information in order to achieve high accuracy and speed. So organization and restoration of information, see, computer integrated manufacturing is totally depend on the data. What are the data you are going to provide for this particular system or technology, that is very crucial for SIM. So the organization and restoration of information and data is very important in SIM. The basic aim is to achieve the goals of the objectives within limited available capital. So within certain constraints and limitation, you have to achieve this. It is not like that you are going to apply or implement SIM in an industry such that the industry is having a heavy loss right now, or it is not up to the mark, they are not providing the funds required for this, then how you are going to uh, apply this? Okay, so you have to work on the availability of the capital. That is the limitations you must know. Traditionally, all the efforts were focused on achieving single goal that I have already explained. The single goal is the having or getting more profit, more and more profit. How we are going to get this? By having a effective and competitive organization. If your organization is effective, the productivity is good, the efficiency is good, you are competitive enough, the product is competitive enough, then only you are going to achieve that single goal. So this is very important task again. Okay, now the SIM basically involves the integration of advanced technologies, as we have discussed, the CAD, CAM, CNC systems, robots, etc. Now today, SIM has moved a step ahead by including and integrating the business improvement activities, not just technologies, not just manufacturing related activities, not just designing related activities, but business improvement activities. This is a management part of the total organization. Okay, now what are those things? Like customer satisfaction, total quality management, and continuous improvement like Kaizen systems. These are management activities which are focused on improving the overall business function or business functionality of the total business or organization. Okay, now these are integrated and included in the SIM nowadays. Earlier the SIM were focused on the advanced technologies and data processing, data communication, but now these management philosophies and activities, or business improvement activities rather, are integrated in them. And how they are managed? They are managed by using computer. Business and marketing teams continuously gives the customer feedback to the design and production team by using networking system. This is a very important thing. Okay, so business and marketing team, business improvement activities are related to business. Marketing teams which are taking the feedback, giving out the sample products to the customers or the target group. Okay, and then they are using that, they are testing, they are analyzing, they are surveying. By whatever means they can arrange or collect the data, they are doing that, and that data is being given to the production team and design team so that they can integrate that data into their system. They can use that data, conclude from that, and use that particular conclusions in the designing phase or in the manufacturing phase. This is how these all things are going to work. As I have said earlier, the data or the database is very much important in SIM, computer integrated manufacturing, since it uses common database and communication technologies. Like on a shop floor, if you have 10-15 CSC system and you want to communicate the data with the from server to all these CNC systems, you must have some communication technologies. Okay. Now, why this is important, or what is the objective behind that? To integrate design, manufacturing, and associated business functions. Three things: design part, manufacturing part, and associated business functions. Okay, that combine the automated segment of the factory or a manufacturing system or facility. So basically these three things are going to be combined using common database and communication technologies. Benefits of SIM. What are the benefits? SIM plays a vital role in the economy of the manufacturing system or enterprise. Basically, it is a very vital or crucial part of the improvement in the economy. If you want to improve the economical part of the industry or factory, it is very important. The benefits are product quality improvement. Obviously, the quality is going to improve. Shorter time in launching new product in the market. If your communication with the customer, since in last previous slide I have discussed that the marketing team is going to make surveys and analysis and research on the customer needs. They are providing this data to you, and you are integrating this data as a concluding part in the design. So you are making a new design. So whenever you are making a new design, the new manufacturing and the new product is going to be launched in the market. Now, earlier, without using SIM, or earlier days, it was very difficult because there were no computers or these types of systems. So no feedback was coming to the design part or design department. So they were only focusing on the refinement of the current product only. But now these things are coming as a feedback, so they are integrating just new feature to their product, and the time required for launching that product was very high. If you remember few earlier in this era of 2010, 5, 10, or up to 12, 13, the for an example, if you take an example of a mobile phone, the mobile phones versions were hardly two or three versions were launching of a company in a year. Hardly, because the technology or the customer feedback, all these things, and the time required to launch the product was very high, because these things were not available to them. But now it is very much available. The systems have become very virtual, okay, and very fast. Now what is happening? Every month they are launching two variants, three variants of a product, or every 3 months they are having 5, 6 variants of a mobile phone. This is how new product launch in the market, the time span has been reduced. Next advantage is flow time is minimized. The flow time, if you remember that part, inventory level reduced. The level of inventory, raw material, whatever the raw material you require, and whatever the in process material, that is another type of inventory. Okay, so this level is got reduced. Competitiveness increased, obviously, and improved scheduling performances. Scheduling is improved, vendor lead time is reduced, customer service is improved, flexibility and responsiveness is improved, total cost is getting minimized, long term profitability increases, customer lead time minimizes, manufacturing productivity increases, work in process inventory decreases. Okay, so these are the benefits of SIM. So if you want to write it in the statistical way, how we can write it as 15 to 30% reduction in engineering design cost. See, 15 to 30% is not a very less amount for a big industry. Okay, so 15 to 30% reduction in engineering design cost, 30 to 60% reduction in overall lead time, almost 50% if you take an average, 40-50% lead time is reduced. Gain in overall production is 40 to 70%. Quality improvement, see the quality improvement by using SIM. It is 200%, minimum 200% to 500% in quality improvement. This is outstanding, right? 30 to 60% reduction in work in progress. So these are the statistical information of benefits of SIM. By using SIM, you can achieve this. So that is why it is very important that a mechanical engineer must have this knowledge of SIM before going to industry. So that is why this part is included in your syllabus. Okay. Now what we will do, we will stop here because the time is over for this particular lecture. We will start with hardware and software of SIM in the next lecture. So just give me the